Today we're looking at the Ultrahuman AIR ring, a biometric tracking smart ring. Keep watching to see me try it out, take it apart, and analyze the design and manufacturing of the circuitry inside. This video is sponsored by DigiKey. When you order your Ultrahuman ring, you have an option to get a sizing kit first. This makes it easy to be confident about selecting the right size, and the sizing kit can be used as a discount code for your friend after you're done with it. The device consists of two parts, the ring and the charging base. It also comes with a charging cable, but no charging brick. That's a benefit in my opinion, since I already have plenty of AC adapters lying around. The ring has a flat part inside that lines up with the flat part on the charging base. Ultrahuman provided 2 rings for this video, so big thanks to them for being down for this destructive and reverse engineering type review, which they did not get to influence otherwise, by the way. That thicker part of the ring is home to the components for sensing your heart rate. It's got some LEDs that shine through your skin. Then a photodiode detects how much light reflects off your blood, which changes along with your pulse. There are a whole bunch of other goodies in here, so before I break it apart, I sent off the ring to be scanned by my friends at Lumafield. We'll take a more in-depth look at the scans in a bit. So then I began the teardown process in earnest, starting with the charging base. I saw a seam between the top and the bottom of the base and figured I'd try to pry the thing apart at the seam. Well, turns out that was a dumb and unnecessary move because the base is held together with screws. They're just covered up by this bottom sticker. I caused a lot of mutilating damage to the plastic before I realized this mistake. Y'all know I just had knee surgery, right? I'm gonna blame this one on the painkillers. Once I unscrewed the screws, I was left with a small square red circuit board and these flex PCB elements attached. Next up, it was time to take apart the ring. I wised up and took a peek at the scans before beginning this time, so I could avoid cutting through the battery. I used my jewelry bench and a triangular file to cut 2 notches in the titanium shell. Then I was able to pry the shell off by sticking my flat pliers in the notch and twisting them. I was left with the circuit embedded in epoxy resin, which I was able to peel apart in some places. Since the plastic is very clear, it made sense to leave it in place where it wouldn't easily separate, so I could still read the printing on the components. Now it's time for my channel's favorite electrical engineer, David Craner, to join us to take a look at the circuitry inside. Oh, hey David.
Hey Becky. How's it going?
Good, welcome back.
Nice day outside. The neighbors are having a barbecue.
Oh, good thing we have audio equipment.
Exactly.
Today I have to show you the Ultrahuman Ring AIR.
Ultrahuman, nice.
And they sent me 2, so I have this one that I took apart, and then I have this.
And one for Becky Smash, yeah.
Yeah, one for Smash and one for wear. So you can also look at, for once, you can actually look at the product before I took it apart.
It's very cool.
It's very similar to the Aura ring, which we've taken apart in a previous video.
Can't really get much. Oh, look at that little chip antenna.
Yeah, I know, a little chip antenna. You want to? Do we need to change the focus or the LEDs on this?
Some more light, maybe.
Mm-hmm. And like the Aura ring, it has the ring that has inductive charging, and then the little inductive charging base. So it's 2 parts.
Cool.
Yeah, and it's in pretty clear. Clear material, yeah, so it's actually not so hard to see when it's not disassembled. But I did manage to, here, you want to look at the one I took apart, it's a little bit easier to see the components, yeah, because I made it like a little flatter by breaking it. Flatter through smash.
Flat through smash.
So this, I think this is the photodiode that does the, and LED set that does the heart rate sensing,
yeah.
Because that big black part is the enormous photodiode, and then there's LEDs next to it.
LEDs.
One of them's red, one of them's green, and I don't know what the other one is.
Yep, that makes sense. And then, what is that?
Yeah, this little part with the rainbow on it, I cannot seem to read the number. There's something engraved on the top, but I can't seem to unrainbow it.
That's a stress pattern.
From heat, right?
It could be from...
Or is it from me? You're telling me it's from me.
From various things. But it's kind of cool because like you can't see it with your naked eye, but it's the kind of thing you can only see with like polarized.
It's like we're reading this like a book. We're reading it like a book from the left to the right. So we got the photodiode.
Right of the photodiode.
And you'll see that there's a little tag. The Ultrahuman logo starts to cover it up also because it's like, and then if you look at this one that I've managed to get the packaging off of, can you do the same thing? It's that shiny guy. See how, like, if I sort of tilt it this way...
Yeah, I think that's just...
Do you see that there's, like, a QR code on it or something?
Yeah.
You see? But it's got, like, a number. But I couldn't read...
I think that's a stress pattern in the plastic from the bending.
Okay. But anyway, I couldn't identify... I don't think we could identify this component anyway because, like, when I can see what's on it, it's just, like, a number 9011 maybe.
Like an internal...
And, internal Q. Oh, wait, there we go. Look, you focused it. Yeah, like when you have a QR code on it like that, that's usually from the manufacturer themselves, like keeping track of the lot and stuff. It's not a part number.
Can we look at your nail with this microscope real quick? It looks nice. Are those inkjet printed?
I don't know. They're stickers that I bought. So, yeah, it looks like it, huh? Yeah. Ooh, you can see the dots of ink on my nail stickers.
Microscopes are great. Yeah. Cool.
And you can also see the bubbles in my manicure. We're not going to zoom over to my cuticles.
Yeah.
That's not happening right now.
Anyway, back to the circuit.
So, yeah, you can see that there's so awesome. Okay, great. We have just enough lighting on it now to be able to see that it has the QR code on it, but I don't think...
like take us...
we're recording the screen.
You're not going to get anything
We're recording the screen. So we're not going to be able to find any more information about that. This thing, though, next to it has a little number on it, and it has a little shape, like a little domino with 4 little dots
What does it mean?
and a number. What does it mean, David?
I don't know what that thing is. I haven't seen one of those.
But it has a number on it, so we'll look it up.
Yeah.
Here is this.
That's a Nordic NRF 52 series.
Yes, it is. Look at that.
Yeah, N52.
And we know that this is the chip antenna.
I bet that looks cool in the scan.
That
in the scan.
Does the Bluetooth necessary for this Nordic guy.
I always talk about this, but I love looking at RF sections of PCBs just because the geometry matters. It's this like sacred geometry thing, and like look how the trace that leads to it is curved.
Well, that's like if you put it in a straight line, it could be picking up on any of the rogue fields that are created by any of the straight line or right angle traces in the circuit board.
It needs to feed in, and then also like with sharp corners.
Yeah,
electricity jumps off the corners at high frequencies. So when you see really high frequency stuff, there's always has these fun like curvy shapes
to keep the electric fields in.
It's a fizzy thing. Oh, also look at how the molding of the plastic like took the engraving
picked up on it. Yeah,
from the Nordic chip.
Yeah, I'm pretty sure that looking at the way this PCB is, I'm pretty sure the PCB is pressed into the metal frame, and then a squirt of this clear stuff is put in, because like look on the back, there's like areas where the PCB doesn't have any it doesn't have any of that epoxy on it. Yeah. And areas where it does. So like right here, that's what made me think it was like squirted in after the PCB was already in.
It could be like an over molding type process where they have like a injection molding machine that they put it into.
Yeah, right. Because see, look, this is actual flex PCB with no plastic on it.
Yeah.
That was right up against the metal, but then like you can see it kind of like smushes in. But then on the inside where it touches your finger, it's completely uniform. All right, so we have the Nordic chip. Yes, you called it. That is the little Cortex M0
with all the
with Wi-Fi,
stuff,
with radio on it, Bluetooth Nordic, as noted by the big old N.
Yeah.
And then next to it is what? Probably like a crystal oscillator.
There's probably a crystal nearby somewhere.
And then what would this? There's like 2 crystals.
I don't know. I would you could maybe look at the data sheet for the Nordic 52 and
just see what it needs.
Yeah, because often they've got those example layouts.
All right, so that's there. There's this numbered chip. There's mystery chip. There's the photodiode. So these are all on the inside facing your finger. And then if we flip it over, there's like a few little friends over here. It's hard.
Is that an inductor? Is that big square one an inductor? Maybe. No, that looks
No.
like a QFN. That's a QFN.
It's I thought I got the number for it already. Maybe I didn't. I think maybe the thing I got all the numbers for is the charging base, yeah.
HFW.
Yeah, but is there one letter before that I chipped off?
I think so.
And then K52N. So there's a couple more things over here. We know that this board is doing heart rate variability and step tracking and stuff. So it's got to have
an
accelerometer in it somewhere.
Or an IMU with a gyro accelerometer.
So my guess would be that one of these is the IMU, because I don't think that Nordic chip has one, but we can check.
I don't think
Just
so.
spitballing. And that is the extent of the chips on the board. Like this is adhesive. I guess there's some passives back here. There's something going on, like a whole row of passives right here.
Where does the power come in? Where does the inductive charging happen?
Oh, it happens under the battery. Sorry. So great. So here we'll move on to the other part of the ring.
The other side. Okay.
Yeah, and I didn't delaminate it enough to see, but we'll be able to see it on the scan. This whole, because I didn't want to break the battery open. This whole piece is got the battery in it, and then the inductive charging coil is layered on the inside of the battery. There's the charging base. So now, so I've shown you the ring, but now I should also show you the charging base. Which is USB-C to plug in, and then it has this charge indicator light. That's an RGB LED, yeah. Why does it have so many wires? Why does it have more than 3?
I don't know what's going on there, but look, the lead frame only has 4 contacts.
Oh right, okay. One for each color, and then one for power.
But there's ground. Is it a smart LED? Is that
maybe?
Why?
Oh yeah, maybe, because look at others, and then there's the little chip on the inside.
There's a lot of chip, but I only see yeah.
I don't know, but if this were a spider I saw in the bathroom, I'd probably kill it.
I'd smash it, yeah.
There's also this little connector.
Love those. Those are fun. Yep.
You get another view of my little nail sticker. Yeah, a little flex connector. So it has these little metal pads there and this little door, and that joins up with this little friend. Goes in there, and then the door closes. Boop, boop, boop.
So do the contacts go up?
I feel like it goes this way because look at the way it's bent. Just because I know that the product was like this.
Also, when you do those flex connectors, you have to click them in too.
Oh, look, I didn't. Yeah, you can see that it's moving.
It's like the black part.
Yeah, the black part needs to like.
And click it back. Oh, these things are such a pain.
I don't think it does.
Really, it doesn't?
I don't think it does because it made a click when it went down.
Okay.
Anyway.
Can you pull it out?
No.
Oh, it's pretty in there. Okay, good.
It's in there, but yeah, it's not meant to be like strained upon. It's like it's supposed to be inside the enclosure. And this is the inductive charging antenna. It has those 3 little, or I guess 4 little wires that go into two little wires. No, 4. It has 4 separate wires.
Yeah, well, that's just to get more power through the connector.
Ah, okay. And then it has a little flex PCB coil.
Coil, yeah, it's an antenna.
Boing. But as an extra bonus, it has boing, boing, yoing. It has a second one.
A second one, and this is from inside the charger.
Yeah, it's like in
but
this.
I wonder
it's
why,
in this
because
part.
the ring only has 1 input coil, right?
Yeah, I thought at first it was so that you could put it backwards on the charger and put it on any orientation on the charger and charge it, but it really is keyed onto the charger with the flat part. So I don't understand. I did, however, when this ring was still intact, this is a larger size ring, and I tried to put it on that one, and because it's bigger, this plastic is a different size, and I was able to free rotate it, and it was still charging the whole time. So I don't know, maybe just because it doesn't cost any extra to have this second coil. I'm a little confused about why it has the second coil.
I don't know. I mean, it could be a thing where part of the design was done already, and they just didn't want to go back and redo it because it wasn't going to change anything.
Yeah,
but I mean, they did make these plastic parts to put coil in and stuff.
2 coils.
Yeah.
So that's a little bit of a mystery.
Oh, no, that's interesting.
But this thing has the typical stuff you'd find. I started charting out the list of chips on this board. So I will, as usual, I have the write-up for this teardown on my website, so you can look at all of the chips that we could find and identify. But the main one is this guy.
STM32.
Yeah, our good friend ST Micro, holding it down with the...
That's definitely going to be a beefier
M
chip.
Cortex.
Yeah.
This is an M Cortex M0 microcontroller.
It's also M0. Okay.
Yeah.
Yep.
And it also has some flash on it. And so this...
Those are nice microcontrollers. I like them.
This one would be used for what? Communicating between the ring and the charger? Like, oh, the ring is detected, start charging it. That kind of thing?
Yeah, and then also it's running any logic, so it's probably... Like, does the ring send stuff to the computer if you plug the charging base into the computer, or does it just charge?
No, it connects Bluetooth to your phone.
I mean, it's probably just talking to the ring. It's probably managing how the charging works.
I think the base just talks to the ring.
It's a reasonably beefy microcontroller, so...
So why does it need so much flash?
So much beef.
Do you think... Okay, here's an idea. If the ring doesn't have a lot of flash on it, and this thing is supposed to store health data, tracking biometric data, I wonder if it's possible. No, because the charging coil doesn't transmit anything but charge. It's not like also telling the base, like offloading some of the data to store or anything. No.
You can send data over that channel.
While it's charging?
Well, you could like multiplex it.
Okay, I think that's a bit of a stretch. I think that ST microcontroller is on there because these days they're no more expensive than the formerly cheaper alternatives.
Like RFID cards, are both powered and send data through.
Yeah. Yeah.
And then there's just probably just like a lot of like power conditioning stuff on here. Yeah, and the microcontroller is probably also controlling the state of this LED.
Oh, yep.
And it's probably controlling I bet it's controlling how the charger works. I bet the microcontroller is managing the charge and controlling the LED.
So it detects when the ring is present, charges the ring, maybe controls the rate of the charging of the ring also, so that it's,
It could be, because this charger is kind of a custom solution, right? Should we look at the scans?
Yeah, okay, let's switch to the scans. Yeah, thanks to our friends at Lumafield, who are so gracious to scan gadgets for my teardown videos.
Thanks, Lumafield.
Thank you, Lumafield. They have also provided us with some lovely bookmarks on our scans, which makes us look really smart when we're navigating the scans, too. And they built this software also, this CT scanning, browser-based, like CT scan navigating software that...
It's pretty great.
It's, worth noting that that's also a Lumafield production. A Lumafield joint, if you will. I always love these things that combine metal and plastic. The little charging bases for everything to me are almost just as interesting as the wearable device itself, because they have to integrate with, they have to mix the bridge, right, between the regular land of gadgets and the wearable gadget that's touching your body. So you can see here that flex PCB from the connector coming up, and
it's just nice to see with these tiny things, just the level of integration that they have in their designs is just always so nice to look at.
Yeah, and we saw on the antenna here that the antenna are actually affixed to their own little pieces of plastic, and then those pieces of plastic fit up inside the lid to the box. And that has to be because this piece of plastic here is a different size depending on what size the ring is. Yeah. So this way, this little antenna, this set of parts, can go inside any size
and
enclosure.
And then they just change the
lid even, not the base. Yeah, the piece on top.
Perfect.
And so they do have a top piece that's a different injection mold for every size. And that makes sure that the ring fits securely.
Are those coils exactly the same? If you look at them straight, do they have the same number of wraps?
Yeah. I think so.
Interesting. Only one is used.
No, I think both of them are. Well, yeah. I don't know. The thing is, like I said, I did put the bigger ring on the smaller charger and was able to charge it flipped around the other way. So maybe it's for if you... This seems like an edge case to me, but say you're an Ultrahuman family and everyone has one, and you want to be able to charge the bigger ones on the smaller stand where it's not going to register tightly. Like, I did notice that the bigger ring does charge on the smaller stand.
Yeah, maybe they have got different versions of the top part of the enclosure, so like the big one always goes with the big one. Is that,
it does, but I'm saying like why, like one use case is that like I was able to charge the bigger ring on the smaller charger because it had in a different position, but I don't know. Anyway, you can see the registration shape here. Like there's this flat side here where the ring is bigger, so that always makes sure that the ring is in a particular orientation. Then
look, if you look at it at the top, you can see the helix on the screws. Yeah, that's pretty cool.
They remind me of ice cream cones. So the enclosure is screwed together through the PCB with those 4 screws on the corner. You can see our little oh, I think we want to slice into it now. Here's just the metal bits. So you can see the chip footprint.
You can see the chip footprint. You can see the legs on the chip. You can even see the solder joints on the legs on the chip.
Yeah, this one is just metal. This is a cool scan. And then here is the slice.
It's cool you can see the solder joints, because like this type of CT scanning technology, like beyond making cool YouTube videos, is really useful for like, you know, inspecting things like qualities of solder joints and other stuff. And
yeah, so one of the things that one of the commercial applications Lumafield advertises is QC and QA of manufacturing processes. So yeah, the fact that you can see the solder joints means you can also quality check the solder joints and like see if there were any shorts or incomplete flows or stuff like that. Yeah. And then if we switch,
I like that you can see all the vias the going through the circuit board too.
Yeah, and so if we switch to this overhead view, that's going to allow us to peel back the layers of the PCB.
Oh, we're slicing out from the top now?
Yeah.
Oh yeah, you can see that. You can see the slice plane. It's so cool.
So here's like what the USB-C port looks like in the middle, and then they're getting into the LED lead frame and the connector for the flex PCB. Like these are the taller components. And then when we get down to the layer of the circuit, there's just the top layer of the circuit board itself. And then there's all your vias. This is the scan of the base. Do you want to look at the scan of the ring?
Yeah.
I am a scan of your ring. Do you have components hiding from me? Not anymore.
Not anymore.
Here's the charging coil. You can see it's the same size and shape as the ones in the charging base, but see how there's not one on the other side.
Let's look at the chip antenna.
Look how cute it is.
Can we slice through that thing?
Yeah, we can.
Look at the layers inside the battery. So yeah, so it's like if you're, you know, when you're making a product, you can't
look inside it here.
And you can't see how good the solder joints on the BGAs are either.
No, and even if you were to take it off and look, you wouldn't be able to tell how good they were when it was connected. This is the only way to tell once it's already assembled whether or not it's all good. What were we looking for? A slice through?
The slice through of the antenna.
The chip antenna. So that chip antenna basically does what like a big long wire would do, but in a very small shape, yeah? So that you don't have to have a like Nokia cell phone antenna sticking off of your ring to communicate with your phone, so that they can get normal Bluetooth range out of the tiny little package. Exactly. And then there's the BGA, which stands for Ball Grid Array. So that chip, that's the Nordic chip, that's connected to the...
Is it?
Yeah. Connected to the chip antenna? Yes, the Bluetooth thing, this one.
Yeah, oh it is.
No, that's the photodiode, for sure.
You could be looking at the photodiode, and then the photodiode could be sitting on top of some plastic.
So the circuit is here.
Yeah.
And there's like nothing, and then there's this.
Yeah.
That is the part of the ring that's flat. It's like the part that gets fat because of the photodiode sticks up. So like, is it a filter? Because it's not, it's like showing up as like a dense material, but it's not connected like electrically or anything. So like what's going on there?
Can we look at the microscope feed again? It's this part that you're looking at.
Because then the glare is on the other side.
Yeah, there's definitely some like space down in there, right?
Uh-huh. And I thought it was just all clear all the way down.
I see metal. I see that. This looks like metal to me.
Okay. Right, but whatever's on the scan goes all the way across, and we know that light needs to transmit through this thing. You can see it better if you tilt it this way.
What if the what if the light emitting sources in the photodiode have to be a certain distance from your skin in order to give it distance to like bounce back and forth, and there's just a metal piece that
reflects?
that holds it up, so it's guaranteed that they're a set distance above your skin all the time.
Okay.
But then maybe they don't want that thin clear plastic to take all the force, so that's why the component actually has like a piece of metal in it, because it's like actually setting the distance.
Okay, well, let's compare. This looks like it's like a little, like two little squares next to each other.
Because it's probably like sheet metal that's folded around like this, probably.
Okay, and then there's like nothing in front of just the diode, because that needs the light to come in. But I feel like this piece that we're looking at here goes over the whole thing. It could also just be denser plastic, maybe.
Oh, that looks really intentional. Right
Doesn't
there.
it? Yeah. But I mean, like, for...
It's like not I mean, it's... Yeah. I don't know. It's a mystery.
Okay, well, anyway, moving on.
Tell us in the comments.
Yeah, please. We have the charging coil there.
Look at that.
Here's the metal view.
Solder.
So that means to me, because there's no metal, like that the battery's got to be one of those film batteries. Ceramic. Because it doesn't show up as a metal on here at all. Just the tabs.
Oh, you think it's a lithium ceramic?
Yeah. Because we thought that the Aura ring had one, and this one looks the same as the Aura ring.
Catch on fire if we stab it? Yeah.
See, I did not stab it on purpose.
You can cut in the...
I didn't do that on purpose.
The stab test from the...
So here you can see the footprint. Like, this is the BGA footprint. This is the QFN footprint. What is this one labeled? Translucent showing potting voids. What's a potting void?
That would be like holes left in when they added this plastic on the inside.
Oh, like here?
It would show like imperfections. Maybe there. Like, what about those?
Well, that's in the plastic, because that's the wire. Inside
yeah. So like little bubbles. Like, basically we're like looking for little bubbles in the plastic.
I see. But you can also see how the PCB is like not quite as curved as the ring, because like here it flattens out a little bit, and here it flattens out a little bit too.
Yeah.
But see how the battery has these like curved, the layers are kind of stacked and curved at the same time?
Yep.
That's what makes me think it's the ceramic film. Yeah, these scans are really interesting. I could look at these all day. They're like mesmerizing to me. But I also like can watch how it's made marathon, like.
Yeah.
So.
Exactly.
That's the type of person I am.
Yeah.
Well, thanks, David.
Thanks, Becky.
I learned a lot more about how something like this is made, and what a fun, fantastical world it is.
Tiny world.
Yeah, tiny. Little city.
Exactly. All right. Well, I will see you next time.
Okay. See you next time.
Use the stairs.
Okay.
Okay. All right. Bye.
This video is sponsored by DigiKey, which carries tools for your own teardowns, as well as some of the components in the Ultrahuman AIR ring circuitry. Head to the link in the description for more info on all the parts we could identify, and let me know what I should tear down next in the comments. If you liked this video, please give it a thumbs up and share it with a friend. I hope you'll subscribe with the bell to be notified of my future uploads, subscribe to my email newsletter, and find me on your favorite social media platform. Thanks so much for watching, and I'll see you next time. This video was made with support from my sponsors and generous donations from viewers like you through Patreon and YouTube memberships.